Use the given information about the polynomial graph to write the equation. We need a polynomial that is degree 5, has roots of multiplicity 2 at x equals -3 and -5, root of multiplicity 1 at x equals 2, and a y-intercept at x equals, or at x, at 0, 2. Okay, so degree 5, that means we're going to have 5 different zeros. Zeros and roots are sort of the same concept. So by saying roots, it's the same thing as saying zeros. So we have a root or a 0 of x minus 3. So we have a 0, x equals -3, which has multiplicity 2. Then we have a 0 at -5 with multiplicity 2. And then we have a 0 at 2 with multiplicity 1. Now, if you'll notice, that adds up to 5. So 5 zeros is degree 5. So I just need to change this into a polynomial. And what that will look like is this. So to change x equals -3 into a factor, I just move the -3 to the other side of the equation and say that it's x plus 3. So the factor x plus 3 has a 0 of -3. And it's multiplicity 2. So I square that term. And then x plus 5 is multiplicity 2. And x minus 2 is multiplicity 1. Now, the y-intercept. How do we get the y-intercept accounted for? Well, the y-intercept, since it's occurring at an xy coordinate pair, the only thing that would change is some constant multiplier of this polynomial. Because we still need all these zeros to pass through, it's just how high do the peaks and the valleys reach here. And the y value is the same thing as f of x, because it's always a rule in algebra that y is equal to f of x. So I can replace x with 0 and y with 2 and solve. So I would have 2 equals a times, and if x is 0, this would be 0 plus 3 squared, which is 9. 0 plus 5 squared is 25. And 0 minus 2 is -2. Now to adjust for this, I can make it a little easier. If I divide both sides by 2, those will disappear. 9 times 25, let's do it on the calculator just so we don't make an arithmetic error here. That's 225. So we have 1 equals -225 times the value of a. So that means that the value of a is 1 over -225. So the polynomial that meets all of these requirements is -1 over 225 times x plus 3 squared times x plus 5 squared times x minus 2.